This is pretty hard. So let's do it this way. So shuttle is going to arrive at the receptor protein. Okay, and this will be like the ferry dock on the other side. Okay, and then it's going to release something, maybe like another van or something like that. Actually, no, your calcium, it could be at this point, could be your car again. All right, that's not a very good analogy though, but so your calcium is going to continue. It's really going to continue the trip. Okay, it's going to continue to try to accomplish the mission to ultimately get to the muscle fiber. So your muscle fiber is your final destination. Okay, the calcium is going to be what relays whatever from the dock to the final destination. So hopefully that wasn't the best thing I ever did there. But we can go over that in class. All right, the spinal cord often become deformed in cases of degenerative muscular conditions. So you've got in your back, here's where we'll draw a spine here. Spine. I wanted to make it blue. I didn't. I missed. Got your spine. Around it, you've got skeletal muscles. All right, your erector spinae, your latissimus dorsi, lots of other little guys. And it keeps it erect. And when you start wasting away these muscles, your spine contorts. Doesn't have anything holding it up. So you see things like scoliosis, muscular dystrophy, and other disorders that look like spine disorders, but really it's a muscular disorder. Which best describes what causes dystonia? What describes what causes dystonia? So remember, it's a nervous. Okay, it's more of a nervous thing. It's the constant sending of signals to the muscles. The muscles themselves are fine. And okay, this was the one that was all messed up, so I think I'm just gonna skip it. We'll get to it. Good question. Myasthenia gravis is caused by a defect in the transmission of nerve impulses to muscles. Okay, so it's very much like dystonia. It's a brain thing, nervous. It occurs when normal communication between nerve and muscle is interrupted at the neuromuscular junction. Results in atrophy of muscle condition. All right, so why would this result in atrophy of muscle tissue? So what happens when you don't use your muscles? What happens to it? What happens to patients in the hospital? Here's our neuromuscular junction. Here's our muscle fiber. What happens when you don't use your muscles? They waste away. Okay, if you ever have a cast on, your muscles shrink down after you get that cast off. How do muscles get worked? Well, they contract. How do we contract? Acetylcholine arrives here, and it sends a muscle to contract. If this doesn't take place, the muscle never gets a signal to contract. If the muscle can't get a signal to contract, it doesn't get worked. When a muscle doesn't get worked, it atrophies. Okay, atrophy means I want you to know that word. Atrophy means to shrink, to get smaller. All right, so when they're not getting used, they waste away. Atrophy is a wasting. How can we remember that? Atrophy. I never really tried to make a mnemonic device for it. I should. Which sees it happen first in a contraction. All right, a repeat. Yes, can do that one. Get rid of it. Right. I think this might be slightly different than yours. All right, had some Diet Cherry Coke there. Which best describes the primary difference between type 1 and type 2 muscle fibers? I don't know if you have this one. Let me pause. All right, is this going? Are we at a delay? This is a day later. Actually, I just happy my iPod died here, or iPad died, and battery just kind of got charged. So it is now the morning. I don't even know where I left off. So I got some coffee, and I think right here, type 1, type 2, type B muscle fibers. All right. So we are looking specifically at just skeletal muscle. Okay, so we look at different skeletal muscle. All right, you look at your myofibrils. You're going to have really thick myofibrils, a lot of actin, a lot of myosin. You're going to have some thinner ones that have a lot of blood vessels running through them. Okay, and you're going to have ones that are kind of in the middle, a mix of actin, concentration, myosin, some blood vessels. Different functions. Okay, you don't always do the same physical activity. Okay? Your body needs variety. So it has different types of skeletal muscle depending on what you're doing. So let's look at the primary difference between type 1 and type 2. Type 1, think slow, long, endurance style. Endurance requires a lot of oxygen, duration. We can't get tired quickly. Type 2 is fast, explosive, going to use quick energy. It's going to burn out fast, but it's going to provide strong contractions. Okay, so let's get, here's best. Let's get rid of ones that I know are wrong. I'm going to tell you why. They have different proteins in their myofibrils. No, skeletal muscle has actin, and myosin. All right, no matter what. Now these have type 2 has more of it, but it's not. They're not different. Okay? They are used for different types of activity. They are found in different forms of muscle tissue. This is all, like I said, skeletal muscle. They are found in different animals. That sounded like something someone who didn't take this class would pick. No, as we saw with the chicken, muscle is muscle. We all share very similar characteristics. That's very not true. So our answer is different types of activity. Okay, like I described. Type 1 is for more low intensity, high endurance, don't need a lot of muscle fibers, getting tense at the same time. Type 2, power, lots of myofibrils contracting. Okay, we got to do that bench press. Okay, we're doing that heavy squat. It's type 2. So if you're getting ready to do your bench press, all right, you're getting ready to activate a lot of type 2, unless you do like 1,000 reps or something ridiculous like that. The following graph shows the type 1 and type 2 muscle fiber cells in a powerlifter and an endurance athlete. Label which power represents. All right, so before you look at the graph, just think about what you'd anticipate. We would expect powerlifter to have a lot of type 2. We'd expect the endurance athlete to have a lot of type 1. Okay? Label which bar represents each, so which color bar. So type 1 muscle fibers, this is high, and type 2 muscle fibers is low. So which one would expect to have a higher type 1 and a lower type 2? So this black one here would be good. Endurance athlete. That means this white bar would be our power lifter. Fabulous. For each statement, write the fiber type or types which correctly matches the statement. And we got a line graph here. I think it's a little messed up. So let's pick a characteristic. It can be any of them. We could do a line graph. So bar graph, we want to use something maybe differently. So something that is tracking something over a long period of time, or as concentration increases or decreases. So I'd try to pick something other than fatigue. Well, let's see. We could do... I wasn't prepared for this one. I'm trying to think of something good instead of just doing like fatigue level. Or, how about we do amounts of myofibrils and strength of contraction. Here's a cool one, right? So here's a number of myofibrils in a fiber. So we'll do a little teaching here. So the number of myofibrils in a muscle fiber. So different muscle fibers are of different sizes. So we'll just think of which one you'd expect to have more myofibrils in a fiber. So let's go with, and I'll make some stuff up. I don't really need numbers, but it's just going to increase as we go this way. And let's do, this is going to have to find a variable. I want to do strength of contraction, but that, wouldn't differentiate. Myofibril, let's do activation, okay? We'll do intensity would be, shoot, hold on, I'm going to pause this. All right, so I kind of backed myself into a corner here. So I'm going to kind of do two of them. Let's do myofibril concentration, and let's do strength of contraction. All right, so I'm going to get one graph out of the way. This has nothing to do with the different type 1, but as the myofibril, maybe I'll put this on the test. The different test question. All right, so what is the strength of contraction as myofibril per muscle fiber? Concentration of myofibrils in a fiber increases. So we'd expect something like this. Probably some sort of upward line. So as the amount of myofibrils in a muscle fiber increases, the strength of your contraction is going to increase as well. So there you go. Let's look at myoglobin. Myoglobin. Numbers of myoglobin. Let's get my eraser here. Oop, eraser. Oh, this is not going well. Eraser. Where did you go? No, erase. Okay, pausing. Having real problems this morning. Mornings are never a good time to do this kind of thing. Oh my gosh, what is... Okay, so I don't even know where it paused. I don't know what happened. So more efficient in aerobic activities, type 1. Concentrated power, type 2. I don't know if I went over this or not. It paused. I don't know where. Fatigues faster, type 2. Can be found in skeletal muscles. Both. Higher myoglobin, type 1. Known as fast twitch muscle fibers, type 2. Slow twitch muscle fibers, type 1. So I kind of turboed that because I don't even know if I went over it. So I really apologize, guys, if you're watching this. So I don't want to waste your time. Which best describes a muscle fascia. So we've got our muscle, draw it in red. And let's say we're doing our hamstring. So it's a complex group. All right, got our rectus femoris. And we got our, right here. Okay, so a muscle fascia, I'll do in blue. It's going to separate each part of a muscle. It's going to protect them from rubbing together, protect friction. It's going to allow muscles to slide past each other, give it a nice protective layering. Are they going to connect muscle to other tissue? No. We want to avoid connecting. We want sliding. Let's get rid of that. Tissue that allows for increased flexibility. No, it's like a wrap. So remember, it can decrease flexibility. Your job is to stretch that fascia out to get it more flexible. A protein that aids in muscular contraction. So a lot of times my D ones I'll do last, and they're really not right at all because I need to run the wrong answer. No, that's like actin myosin. A tissue that separates a muscle from other organs or body parts. Yep. It's like a lining, a protective cover. How does regular movement? Gosh darn it! How does regular movement and stretching impact muscle fascia? So remember, you've got your muscle, all right, and it kind of builds up this fuzz, right? And fuzz isn't good. All right, that fuzz gets sticky. So these start attaching to each other the longer you go without moving. So when you move, watch this magic. Oh, you start taking away that fuzzy connection between the fascias, and it allows you freer movement. Okay, you get more of a sliding instead of a sticking. It allows the muscle. No, we don't want a strong connection to our fascia. That means you're not flexible. It allows the fascia to grow and become stronger. No. Okay, that's no. We don't want the strongness to become stronger. Fascia to become stronger when we're talking about stretching. Kind of want to loosen it up, weaken it in a sense. Prevents the muscle fibers and fascia becoming weak and breaking down. No. Okay, that's what exercise does to muscle tissue. It helps break down the adhesive material. Yeah, adhesive. Okay, so there's a word that we learned about. Adhesive means stick together, so it prevents the sticking together. So when you're stretching out this morning, or when you're watching this, it's probably not moaning. Maybe Friday morning you want to watch this. Hopefully you get some use out of it. Hopefully you just fast forwarded through that stupid graph that just kind of almost ruined my day. All right. You were dissecting a quadricep muscle in an animal. Ooh, it sounds like fun. Should do that. Describe how the fascia would appear and organize in the quadricep muscle. All right, so let's say you got your quadricep. Let's just draw it like a non-anatomy student. Here's a quadricep, right? Well, quad, it means 4. And I drew a picture for you. It wasn't the best in black and white, but you can see here better. The quadricep is more than just one muscle like they taught you in Lifetime. Okay, Lifetime lies. All right. If you look at it, you got your rectus femoris. Yeah, you've got your vastus lateralis. Lateralis, for review, means the outside. Lateral. Medial means towards the middle. All right. So that's that little teardrop you get on your quad when it's all ripped. So each one of these muscles has a what around it? It's got a fascia. So you'd expect to find a group of muscles that are separated by a fascia. Now these all work together to perform a function, but they're separated by a fascia. Okay, so you would not have one fascia surrounding them. You would have multiple fascias. That would let you know that you're looking at different muscles within the quadricep. All right, sip of coffee. All right, this one's pretty simple. So what do we got? Um,